The log base 3 of 1 over 81. Okay, so what I want to do, I want to change this and put this in exponential form. Because when I do, I've got 3 as my base, so you have y3 to some y exponent equals 1 over 81. So what I want this right side to have is the same base as my left side, correct? I want it to have a base of 3. So let's change 81 to some base of 3. Well, that's 9 times 9. And then 3 times 3 times 3 times 3. So basically we have 3 to the y equals 1 over 3 to the 4th. But I can't drop the bases right now because that 3 to the 4th is in the denominator. So how do I take that 3 to the 4th in the denominator and put it in my numerator? What rule do we know?
The power rule? No, quotient rule.
Not necessarily. It's a rule about exponents. What if we made this negative? Because, tell me this, if you have any x raised to a negative exponent, will that not make 1 over x to that positive exponent? So just go in reverse. Take this 4, make it negative. You have 3 to the y equals 3 to the negative 4. Right?
So you just made it negative in that one house.
This is a definition of negative exponents. Right? If I have this,
So
let's work in reverse.
Okay, I understand.
Okay. All right, so now your bases are the same. Drop the base, set the exponents equal to each other. Y equals negative 4. Okay? Does that one make sense? All right. Look at this one. Log base 32 of 2. Once again, this is a logarithmic expression we're trying to evaluate. So I'm going to take my base, which is 32, raise it to some y power, and make that equal 2. This one's a little bit different because you're raising the larger base to y to get the smaller base. All right, so this is different than the one we just worked. But we still have to take 32 and give it a base of 2. So how do we do that? Well, let's break 32 down. You've got 8 times 4, and then 4 times 2, 2 times 2, and 2 times 2. So 1, 2, 3, 4, 5. So 32 is the same thing as saying 2 to the 5th raised to the y. Because 2 to the 5th is 32. And 32 is raised to the y. Correct? All that equals 2. Well, if you have a power raised to a power, what do you do with the exponents? Multiply. 5 times y gives you 5y. All that equals 2. Base are the same. What is this one raised to? What's the exponent here? 1. So base are the same. Drop the base. We've got 5y equals 1. Divide by 5. Y equals 1/5. Okay? Does that make sense at all? All right. 13 and 14, we are expanding. All right. So when we expand, we're going to use these properties. Okay? 13 says log base 6 of 36x y squared. So look at the 3 properties we have. Work in order from top to bottom. What's the first thing we can do? What's the first rule or property we can use? The product, right? I don't have a quotient, so I'm not going to use that one. So let's do the product first. I've got 3 terms, 36x and y squared. So I'm going to split them up. They're added together. We get log base 6 of 36 plus log base 6 of x plus log base 6 of y squared. Correct? Is log base 6 of 36 done? Yep. There's nothing I can do to it. Log base 6 of x, there's nothing I can do to it. This one has an exponent. Correct? So this 2 can come out front. So now we have log base 6, 36 plus log base 6 of x plus 2 log base 6 of y. Now we're done. That's all we can do to it. Does that make sense? That's it. All right, attempt 14 real quick. Ain't that cold here right now. Log base 3 of a times the square root of b all over 12. Right? Let's work quotient first. We know we've got a quotient because we're dividing, correct? So let's take, we have the log base 3 of our numerator, which is a square root of b, minus log base 3 of the denominator, which is 12. All right, log base 3 of 12 is done. There's nothing else I can do to that one, correct? But I have two terms that are being multiplied together, right? Now, one of my terms has a radical. Let's take that radical. Let's make it a rational exponent. What power is b being raised to? Well, as right now, b is just being raised to the first power inside the radical, right? Outside, we're taking the second root of it. So numerator is the power it's being raised to. Denominator is the root we're taking. So that's 1 over 2. So we have log base 3 of a, b to the 1/2, minus log base 3 of 12. Correct? All right, so now, split these up. You've got two terms being multiplied together. Use the product property and split up a and b to the 1/2. So you have log base 3 of a plus log base 3 of b to the 1/2 minus log base 3 of 12. What's the only thing left to do? Move the 1/2 in front. So we have log base 3 of a plus 1/2 log base 3 of b minus log base 3 of 12. Now we're done with 14.
That happened.
Do what?
That happened.
It's better than none of it.
I just didn't.
Use the power?
Yeah, I didn't use the product.
Oh, okay. All right, questions on expanding? Just use these rules. These rules are going to be on the board when we take the test. So, you shouldn't have a problem with that. All right, 16, we are condensing. All right. With this one, let's see. How about we go ahead and work in reverse? We'll start down here, and normally the last thing we do. All right. We normally do power last. Let's work that first. Now, the way we go in reverse with the power, take the coefficients, put them back as exponents. So that 2 is going to go back over to m. The 6 is going to go back over to n. Now, with this 3, what do you think we're going to do since there's parentheses around what the coefficient 3 is being multiplied by? You have to distribute it to both of those logs. So this is going to be 3 cubed and j cubed. So we've got log base 4 of m squared plus log base 4 of n to the 6th minus log base 4 of 3 cubed minus, or plus, sorry, log base 4 of j cubed. Notice what we have. We have two products and then a quotient. All right? We have a product here, and they're both divided by each other. They're both quotients. Okay? So let's put these two together first. Let's put these two together, and then we'll do quotient last. So m squared n to the 6, that just stays. We can't combine those. We have log base 4 of m squared n to the 6th. All right, minus, what does 3 cubed become? What's 3 cubed? 27. All right, 3 cubed, right? So we got 27. J cubed. What's the only thing left to do? The quotient. That's it. All right, we've got a subtraction right here. So we've got the log base 4 of the first thing we take the log of, so m squared n to the 6th, divided by the second thing we take the log of, 27 j cubed. All right. Does that make sense? Are we good with that so far? I mean, there's really not a ton to cover in this. I want y'all to work number 20 though. See if you can work number 20. Put that left side together, correct? And make one log. Multiply the two things you're taking the log of. So x times x times negative 3. So we have the common log of x squared minus 3x, all that equals 1. Well, now there's nothing else I can do with the log, so the log's going to stay there if I keep it in logarithmic form, correct?
Correct.
What other form do we know? Exponential. Logarithmic form is the inverse of exponential form. So, how about we take this, put it in exponential form? What's the base? It's common log 10. If there's nothing there and it does not designate what your base is, it's a common log, it's always 10. So we've got 10 to the first power, which is, we just leave it as 10. Okay? So we've got 10 equals x squared minus 3x. Now, if we move that 10 over, this is a quadratic. It's a quadratic anyway, but we'll move the 10 over, it's for sure quadratic, and we can factor it. Correct?
Where'd you get 10?
It's the base. It's common log.
10's common law.
10 is the common base of the common log. Alright, so move your 10 over. That leaves you with x squared minus 3x minus 10 equals 0. I can factor that. Correct? When I factor that, that's going to give me what? I need two numbers. There's two sets of factors for 10, correct? My leading coefficient is 1. So I've got x and an x. And all of it's equal to 0. But the two numbers that are going in here, they have to add up and give me negative 3. And I have to multiply them and get negative 10. Alright?
You might just write it down.
Hold on. You go hands front and back. Yep. Alright, so what are two numbers? Multiply, give me negative 10, add up, give me negative 3. 5 and 2. Which one has to be negative? So 5. So x minus 5, x plus 2. Correct? I have to set both those equal to 0 though, right? So x minus 5, that's going to make x equal 5. This will make x equal negative 2. Alright? We good there? That is it. Now,
That's it, alright?
in this case, this negative 2 is really an extraneous solution because if I plug that in here, I can't take the common log of negative 2. I can't take the common log if I plug in negative 2 and get negative 5. Now, because 10, there's not a power I can raise 10 to and get negative 2. There's not a power I can raise 10 to and get -5. So technically, this is extraneous, and our only solution will be 5. If you write both of these down, I'm not going to count off a ton. I'm going to count off at all. I'll just write extraneous solution, and this is your answer. Does that make sense? Does everybody see why -2 can't be an answer? Okay, but if you work it like this and you get x equals -2 and you don't say extraneous, I'll just write extraneous out beside it, but you know. All right? That's the test. If you can do these things, you can work the test. Now, the study guide is long. The review is long. But you're also going to turn in the review tomorrow for a test grade. All right? The review is on page 212, 21 through 44. Okay?
It's gonna be a test grade.
Test grade.